Hello there. So today we'll be doing equivalent pairs. You are given a list of integers, nums. Return the number of pairs I is less than j, such that num I is equal to num j. We're going to be doing a constraint of 100,000 items, where n is the length of nums. So in this example, we have 3, 2, 3, and 2, and 2 in our array. The output is 4 because there are 4 total pairs. So if you look at the bottle below, it's so first pair is the 3 and 3, 0, 2. The second pair is 1 and 3 and 1 and 4. And the last pair is 3 and 4, which is the index of the 3 2s. So to do this, if we want to index and we do this via brute force, it would be n squared O of n squared time, because we can go through for every I, basically for every I in num, length range, length nums. We can also do, instead of range, we can do enumerate for easier access of the number and the I. And then we can do for j in range, starting at I plus 1, so we don't count the same thing twice, and then we can grab all the way up until the length of nums. And that should give us our answer. So if num is equal to nums j, we can get a set total plus equals 1. And then we can return the total. Total is equal to 0. So if we run this, we are going to get a good answer, as you can see here. But this is no good in terms of our time complexity, because we don't necessarily need to find the index pairs. We're just trying to find the total. And that means for every similar number, there must be a number of times we can find it. So for example, if we, let's do some code here. So suppose we do have 3 3s. So how many times can we see this? We can see the 2 3s in front twice, 1 3 in the front, and then 0. So suppose we have 4 3s. So it would be 3 times, 2 times, 1 time, 0 times, and suppose 5 times, so that would be 4 3 2 1 0. The formula here is this is going to be 5 items. So 5 items would be a 4 plus 3 plus 2 plus 1 plus 0. So 4 plus 0 is, let's just say that's, let's say n numbers, and we do this, so we have 4, and then we have 2, we have 3, and then we have 3, and then we have 2, and then 1. So to do this, let's say we split our numbers in half. Let's just do that. So we have a total of 5 numbers, and we split it in half. So that's n divided by 2. It looks like it's an n minus 1 because in the 5 we get, we start at the 4, so it's n minus 1. So it's n minus 1 times n divided by 2 is our number for the number of counts for a similar number. And once we have that, we can scrap this. We're going to create a counter to count the number of times each number exists. So we're going to still set the total to be 0. And this time we're going to go through all the values of the counter. And we're going to run total is going to plus equal this formula of n minus 1 times n divided by 2. And then we're going to return the total. We can totally just comment that out. Do a run. It looks like it's good to go, and we do a submit. This should give us an answer of right there. And so that is equivalent pairs. Is there any way to do this faster? Let's see. So we're doing O of n time, and that is really fast for this problem. And we're getting the total via the formula. Also, let's talk about like maybe if you don't find the formula, what can you do? If you don't find the formula, you can also just add up these numbers, I in n, and just total plus equals I. That's another way to do it. Lang I, range I of n, because that adds up all numbers up until n, and that also gives you another answer. So let's see. I'm trying to think about like how we can speed this up some more. Is there a method? Maybe it's because of the counter that I am slow, but I mean, what if we count up all the similar numbers? Would that be the same? So if we find a similar number x times, would that be the same as 5 threes? So suppose, is this the same? 5 threes and 2 twos, like that. Is that the same as 3 3? And the answer, I don't think it's the same, because if this would probably, so this is 6 items, 6 5 4 3 2 1 0. I can only find 4 here, and then 3 2 1 0, and then I start off at 1 and then 0 again. So I don't think we can put them together like that. Is there anything else I can do? I'm pretty sure this is it. Maybe I'll check the solutions and we'll see how other people got the 99%. But that's all I got for you. Thank you very much. If you like the material, please hit the like button. If you like this channel, you can subscribe. And if you have any comments, questions, please comment below. I'll check it when I check it. All right. Thank you very much, and have a good one.